Hola Calc, we are continuing the trapezoidal rule, but we're looking at it off of a table today instead of off of the graph. So the table below shows the temperatures from noon until midnight, and I'm going to venture to say that that's not during the month of December because we could only wish that it would get up to 70 right about now. But the question is, find the average temperature for the 12-hour period. Now you want to make sure that the key word here that you're looking at is average. The minute you see the word average, you want to remember the whole 1 over b minus a, integral from a to b of f of x dx. And that's going to represent our average temperature. The only problem when we're looking at this right here is the fact that we don't know this. We don't know this. There's no function for us to take the antiderivative of. We have a table. So we have to use an approximation method. And you could think, oh, I could use rectangular approximation method, but take a look at the title. What's it say? Trapezoidal rule again. So we are going to use the trapezoidal rule. So using the trapezoidal rule, we have 1 over 12 minus 0. We're starting noon at 0, and midnight will be 12. The integral from 0 to 12 of our function, f of x dx. So that's the average temperature. Using the trapezoidal rule on that, we're going to let the 1 over 12 hang out on the outside. Then we're going to bring in our trapezoidal approximation. Remember, that is b minus a over n times 1/2. Some people like to think of it as b minus a over 2n, and you can do whatever you want to help you remember that. Okay, so I just paused the video because someone walked in the room, and I really don't know where I left off, so sorry for the jumpiness and if I'm repeating myself right now. So the 1 over 12 on the outside in blue represents the average temperature for the 1 over b minus a that we're working on. The 12 minus 0 over 12 times 2 represents the 1/2 b minus a over n for the trapezoidal rule. So now we can continue on with big old parentheses, the first value in our table plus 2 times the second value plus 2 times the third value, and so on. Because I write ginormous, I'm just going to go all the way to the end. 2 times 58, and the last endpoint of midnight on its own there. So this represents our average temperature of using the trapezoidal approximation on the table. So simplifying this, do you see how we have 12 minus 0 over 24 represents 1/2 times the 1/12 is going to give me 1/24 on the outside. So then on the inside I have 63. 2 times 65 is 130. 132. You should be able to do all of this mental math. And you might be thinking, do we get a calculator? Maybe and maybe not. Your test is going to be separated. So we'll see where these questions lie. And I'm going to jump down to the bottom again. 138, 136, 136, 130, 128, 124. Holy moly, I have to have a third line. 116 and 110. So moving on to the next page, because I ran out of room, that would be 1 over 24 times the big old number of 1,564, or approximately 65.167 degrees. You better make darn sure that you are taking it to 3 decimals, people, and that you're giving me the units. I am tired of taking off points for people not giving me 3 decimals and not giving me units in word problems. Don't be that person. Okay, so let's go back and talk about the table for a second. We were going from noon to midnight in 1 hour increments. What if the intervals were not the same? What if I only gave you noon, then 3, then 5, 6, 7, then 9, 11, and midnight? Would you be able to use a trapezoidal approximation? You might have said no, but the answer is yes, you can. What would be the main difference? Think about that for a second. Well, you wouldn't be able to do the whole b minus a, we're not equal. Oops, I forgot. Wait, I said equal. Oops, sorry about that. I was right with my question mark. This is what I get for doing this so early in the morning. Sorry, guys. All right, what if the intervals were not equal? You could still use the trapezoidal approximation, but you would have to do individual trapezoids. You would not be able to use the trapezoid rule with the b minus a over n times 1/2 on the outside. You would have to use individual trapezoids. All right, so hopefully you're getting a good idea of the trapezoidal rule and the trapezoidal excuse me, approximation for graphs and tables. And now you are going to be given a homework from the sub that you should work on until we see each other again. But in case, I'll go ahead and write it down right here. It's going to be page 312, bless you. Page 312, numbers, ready? 1, 3, 5, 7, 11, oops, okay. 1, 3, 5, 7, 10, 11, 12, and then 31 through 34. Okay, have a great day in class today. Try not to miss me too much, and I will see you guys again Friday. Bye.